Hi everyone. How was it so far? You enjoyed it? Yes. Yeah. Great. Okay. So today's talk is, as you probably guessed, is a bit of rock music, a bit of data mining, machine learning, all that kind of stuff. So among the audience, anyone is kind of actively doing machine learning at work? Show of a hand, okay. A few people. And who actually done it in when they were in college or university? Yeah, okay, obviously a lot more. And I guess, you guys being here, very interested in knowing, learning about it. So basically, if I move to let's start with a bit of history. So you guys, I kind of find it always fascinating to go back and look at how history has changed us. So what I'm going to show is a little bit of clip which gradually will come to, full. I mean, it's a bit blurred and then comes, and you could probably guess what it is about. So let's look at, come on, move. Move, right. Let's move. Okay, now you will move. Okay, can you guess who it is? Jimi Hendrix, okay. Now, okay, now, Richard Feynman. Do you know what he's doing? Yeah, it's funny that he did actually both of them, but what he's doing now is he is looking at the unfortunate death of the scientist on the Challenger mission, and he's examining the kind of the washers and the instruments that they used, and he's showing that they expanded when they are frozen, and he's actually doing that experiment. And I don't know if you've watched it. If you haven't, please do, because what he's saying is that doesn't matter what is your theory. It doesn't matter, how smart you are. If it doesn't agree with experiment, then, it has absolutely no value. And he says experiment. Experiment doesn't say experience. So it's not about my opinion or your opinion. It's about experiment. And if you look up Wikipedia, what experiment means, it actually is a scientific method of proving something or affirming something or disproving. So let's bear that in mind when we're actually looking at this kind of topic, which is, is quite fun. Tell you a little bit about myself. So I did machine learning back then around 8 years ago. So I spent quite a bit of time trying to extract arrows as well as text from road marking, and this was before all the kind of growth of the self-driving cars. And so the result was 2 published papers, and unfortunately I couldn't carry on what I was doing, but now I'm getting an opportunity to come back to it. So, do you know what it is? Have you ever listened to music like this? So this is how I grew up, growing up in Iran with the love of music, rock music I had, that was shortwave radio. This is how I discovered music. And I happened to find someone that I really liked, this guy was a showman, and he had a program. I loved it and went to my dad. Dad, you know who I discovered? This is John Peel. His show is great. And then I went to UK and saw this guy. He's super famous and everything else, but I still kind of think that I discovered them. So let's start with getting data. So my data comes from Wikipedia, and Wikipedia data, you might ask that, before I go through the data that I've collected, I need to show that my data is good. And so there has been studies done, and they have proved that the quality of the Wikipedia articles is almost as good as Britannica. And also, some of them are saying that in terms of the focus and objectiveness, it's been sufficiently revised. So, all in all, it looks like a good thing to start with. In terms of number of studies that are being done, this is on the rise. So, kind of gives me confidence I'm on the right track for it. So, the only problem is this is not data. What have been doing is content, and there is a problem with content. I could give you a complete presentation on the difficulties I had to turn it into data, but let's just show you one. This is very simple, showing a range of time when the bands basically were being active. Okay, so I say, okay, I'm going to extract this text and look at using hyphen. And then I see it doesn't work. Why? Because they have used figure dash in some other cases, which is a different Unicode. And then that's not all, Sometimes they have used the minus sign, which has a different Unicode as well. And even in the same article, you see, they haven't been able to kind of stick to the same separator, and they've used, M dash and N dash, which in the eye, they all look similar. Now, I also need to tell you a little bit about the dark side of the Wikipedia. Like anything has got its own dark side. So now, anyone knows the band The Dogs? They would sound like like barking like dogs when they were playing. Anyone? Did you know that Lord Byron had a crocodile as a pet? Or like this Ted and treble tones, these guys were like quite famous in the 50s. Well, they are all hoax. So actually, people do put fictitious information in Wikipedia and call it facts. So, we shouldn't really do this. Or let's look at this. The Shags, it's a band which they couldn't basically play, really. They couldn't keep even the tempo, but Frank Zappa really loved it. Anyone knows the Shags? This is actually real. Sometimes real stuff is more unbelievable. I have actually listened to this. You need to have a look. It's bizarre, but somehow Frank Zappa liked it. So, in the true spirit of Wikipedia, Wikipedia does have a entry on hoaxes on Wikipedia. But basically, what they say is that, please don't do that. Okay, so let's just move on. This is my page. What I've done, I've started just, taking this page and extract information. What information do you see interesting? Okay, we definitely got the info box. That's got so much information. The free text. We are going to use free text as well. And links. So these actually link to the other. And this is something that you could build association, and we are going to use. So the whole process was pretty simple. Go and basically list all genres, rock genres, and from the rock genres go to the artists and their albums, and then just collect it, store it in a Postgres database, and I use Python files for it, Python scripts for it. So let's actually explore the data, right? Now, you guys might be interested that I start, with really heavy machine learning stuff, but it's interesting that people who win data, big data contests, actually, this is what they say, They say that don't do this. Start with simplest model. Start with very basic. And actually, this Claudia Perle, she's won many awards, and this is what it says. Just look at the data, because sometimes you look at the data, you find something that you are not supposed to get, or you don't find something that you will expect to see. And in fact, one of the artists, great artists, is not in my data. Can you spot that? So you got until the end of the talk to spot that. So basically, that's what she does. She just looks at the data, opens it up in like a editor, and just looks at the data and tries to find out patterns in that. Well, this is what she does, but for the rest of us, this is what we probably do. We just visualize it. So this looks at the from 1950s albums, all the rock and related albums. You see that it kind of peaks at 2007. Why? Honestly, I don't know. But could it be because people stopped having interest in putting, contributing to Wikipedia? I don't know. Now, what we can do is also visualize it in a different way. What we can do is basically say, we're going to look at the top 3 genres of every year, right? And then basically put that in a relative, so percentage-based area diagram. So this is what we see. We start with pretty much like folk rock, and then garage rock, and then, going to the psychedelic and punk rock. And I guess, who actually listens to rock music here? Yeah. Yeah, not a lot of excitement, but but yeah, honestly, I would say I listen to a lot of these ones. Now, let's actually do something more interesting. Okay, so what we are looking here is the same one, but instead of getting the top 3, I've taken to the top 10, right? And so tell me, from the list, just choose one. Someone shout something, please. Blues. Blues. Okay. There you go. All right. Blues was pretty mainstream here and there, but I'm in the related ones. So if I click on this is what we see. The blues albums of that time. Okay? Give me another one. Sorry? Okay. Progressive rock. Okay. So this is where it starts. And you could look at, starting from around 1967, I guess, 67, 68. And looking at 68, you see names like Caravan, Deep Purple, and Pink Floyd. And then, obviously, 74, there were lots of, Led Zeppelin. Now, bear in mind that some of these are not necessarily purely progressive rock. They have mentioned progressive rock as one of the genres. Okay, let's try another one. Disco. Right. Where do I expect is it this one? Yeah. Yeah, not very hard to guess. So that's what you see. Anyone, I mean, you guys, Poland is like the heartland of metal. So no one mentioned anything about it. Anyone wants to try metal? Which one? Just heavy. Well, heavy starts earlier. So heavy metal starts early. I mean, you could see even 70s. I guess that's probably Black Sabbath. Yeah. But then you see some here, the Blue Oyster Cults, you know, this is stuff, and then it becomes kind of, you know, the 80s is heavy metal's time. Right. All of this, in addition to data and the code to run it, all of that available on GitHub, so you can check that out. So let's move on. The next one is to, instead of like looking statistically, is to look at and build a model to explain and get more insight. So what is a model? So, I mean, the only thing I could remember when I work for a fashion company, so the first thing I remember that, you know. But reality is a model is simply, as it says, a mathematical representation of a concept with the parameters that, you know, kind of supplies it. So, I mean, probably you had to have fraud check, and in fraud check, they will give you basically one number, and what it means is that they constrict everything into a basic number. But that's not enough. I mean, what you need is basically you need more parameters for it. But the problem is that, you know, all models are wrong. So it doesn't matter how you model it. This is a famous saying. So all models are wrong, but some of them are useful. So it doesn't matter if it's not perfect. So let's try to do that. Anyone worked with the graph theory here? Yeah, a few people. So this is very useful, and it's actually very simple to do. I will show you how this can be done. So basically, a graph is composed of nodes or vertices and edges, or we could call them lines, right? It could be directed. So basically, the directed ones, you know, is the Twitter. I follow you, you might not follow me. But it could be also not directed, and for example, Facebook. You know, friendships are not directed. The numbers of directions I have becomes, you know, degree. And if it is directed, in degree and out degree. And also an edge basically can have a weight, right? We're going to use all of them. So let's have a look at this case. So centrality. So you see, let's see, this is a graph, right? What is the most central node? Yeah, the one in the middle, right? It's got 4 connections, four edges. So when you want to actually explain that, you know, you say, okay, in terms of degrees, this is the most central. Another one actually looks at how many nodes, actually, if you want to connect from all nodes to each other, which node you have to pass through most. So that is the in-betweenness degree. So you see, this 2 and this 2, they've got the same degree, but their difference is that one of them has a much higher in-betweenness. The code to do this is so simple. So all you need is Python, NetworkX, and you could do this in any other language as well. And what you do, you create a graph, and then you start adding a bunch of edges. and then you basically find the degree or basically in betweenness, just calculate it. As you can see, it's very simple. Now, what about if it is a directed graph? All you have to do, basically, you get a digraph instead of, you create a digraph instead of just a graph. Right? So, now, let's model the influence. So you know this guy, Captain Beefheart. So he used to, according to Wikipedia, he used to listen a lot to these guys. So what we can do, we can say Howling Wolf basically influenced Captain Beefheart. How do we find out? Because the time that they started, whichever is earlier, I assume this is going to be influencing the other. So I use the links in the articles. So based on the influence, if I use the out degree, this is what I come with. Number 5, number 4, 3, 2, and 1. I guess you guys knew who they were, but basically this is the names there. And what about centrality? It actually changes a little bit. So Nirvana comes to the 5th place, Led Zeppelin, Bob Dylan, the Beatles. But you see, Jimi Hendrix is the most, in terms of in-betweenness, is the most influential artist in rock music. Now, I could actually do this if I filter based on genre. So if I use heavy metal, this is what I get. The most influential was Metallica. Do you agree? I don't listen to much of heavy metal, but I think that's probably very accurate. The alternative rock. What do you think? Who do you think it was the most influential? Sorry? Sorry? Nirvana. Well done. Well done. Yes. Yes. So progressive rock. Wow. You've seen this talk, have you? Right. No, well done. Well, obviously this is based on this data. Now I picked a subjective subject for this talk to actually see what we can get out of it, looking objectively. So there is another one, which is called PageRank. This algorithm was created by Larry Page from Google, and it says whoever has more influence, has more connections to, right, is best. But that's just degree. But you can basically compare who has connections from the people who already themselves have most connections. So what do you expect this to find? I would expect, obviously, because it has to go back in history. And it does. I mean, it goes back to the blues. You see Blind Lemon Jefferson, very high, coming very top, because these guys basically influence the influencers. And you see Robert Johnson, all these blues artists. But you see other names as probably you can identify. So I could use this also in terms of the various genres. And you could see, sometimes changes a little bit. Progressive rock, Pink Floyd suddenly came up. Right. Now shaping a model. So these are models that existed. Now we want to create a model. Okay? How to create a model? First of all, you need to look at what other models are there. You know, don't create your own. But if you have to do that, go and look at the other disciplines. Maybe mechanical engineers, they've got a model that you could use. The other one basically is that you could find nothing, and then you say, okay, I'm going to create one. But when you create one, you need to definitely use something that is a quantitative metric that you can measure and say, you know, my model actually is doing good or doing bad. Or if I change my model, how my model is doing. So now let's create one. Visionaries, right? So how do I define a visionary? So visionary is someone who actually influenced rather than being influenced. Okay, if I define that and create a mathematical model for it and say, so my degree plus is like the people I went out and influenced, you know, divided by exponential of my of the people I got influence from. Let's try visionaries. So the data, this is what we get. Joni Mitchell comes at the top. It's interesting. I mean, when you look at, I was a bit surprised by that. But when I looked at this, so Mitchell, Joni Mitchell is obviously highly regarded, and she does have her own genre. Also, I see Jonathan Richman. Anyone knows the Modern Lovers? So that's a band that he was from, and basically it's got quite a influential band. Now, we could look at that in terms of the various genres. So alternative rock, obviously Radiohead. I mean, no, who is there to actually say, no, that's not right? Punk rock, visionaries of punk rock. You know, they got to be proto-punk, hence the Stooges. You know, these guys in '67, you know, they were doing punk rock. Art rock, you know, is interesting. This comes with the Captain Beefheart, which we talked about. Right. So let's now shape impact. So impact means that, you know, in a very short amount of time, an artist could have, you know, influenced others, right? So let's define a model for it. So impact is the out degree divided by the square of longevity, means that how many years they have actually been active. So let's look at the data. So Cream comes at top. You know, they were active only for 2 years, I think, in 67 and 68. And here is the other names. I think has been able to find. So one thing that I noticed was Big Star. I didn't know them. Look at that. So it says one of the most mythic and influential cult acts whose impact on subsequent generations was very high. So actually, you know, we've been able to capture that. So let's look at another model, weighted graphs, right? So what I want to do is basically to find which genres basically co-occur, you know, they occur together. And for that, what I need to do is, you know, let's say that for this album, which is one of my top favorites, you know, these co-occurs. So I create a graph and say the value of this connection is basically 1, right? And obviously, if I find another album, I will use that and just increment. Keep incrementing until I come up with the full graph. So genre affinity, let's start with art rock, for example. So what was the most related genre, you think? Well, yeah, alternative rock, and then progressive rock, experimental rock. And I have to tell you as well, alternative rock and indie rock are just so common, and that's one of the problems. They are just too common, and that's why they're coming at the top. And indie rock. So, shoegazing. Anyone knows what shoegazing is? It is, but you know, you heard shoegazing. Basically, the guitarists would just look at their shoes, you know, just doing this. They're just looking head down and just doing this. So shoegazing, again, indie rock was the highest, and then dream pop, alternative rock, and post rock. Now let's look at just build one more, and that's genre affinity of the doom metal. Obviously, you guys probably know more because I don't know much about metal, but doom metal, gothic metal, heavy metal, black metal, and stoner metal. You know, I don't know what that is, but so this is, as I said, based on the affinity of the genres, you could find the weights. Now, let's do clustering on this. One of the things you could do on the social networks is to do clustering. Now, I've done that based on exactly the same graph, and basically the way to do this is to create a matrix. And the matrix that you create is the Laplacian matrix, which you would just basically take the degree matrix minus the adjacency matrix and come up with Laplacian. So the degree matrix is basically, this is a square matrix, and you say every node 1 has got 2 connections, and then you just carry on like that. The node, and then adjacency matrix, you say node 1 with node 2, they've got 1 connection, and you just carry on in a similar way, and then create the Laplacian matrix. And what you do, you basically get the eigenvector of this. An eigenvector, I don't know if you might have done some in the college or university. The eigenvector is basically a vector that, if multiplied by the matrix, basically doesn't change its direction. So in a way, it summarizes the matrix. So this is being used, and the code basically, what it does is that you get the eigenvector, and then you say, okay, the minus 0.2, minus 0.1, minus 0.7, they are in one hand, so they create a cluster, and the 0.3 and 0.7 in another one. So basically, node 2 and node 5 create one cluster, and the other one create another cluster. So I have done that on this data, and this is what I've come up with. So new wave, synth-pop, and electronica, which is what I think pretty accurate. This one, everything that heavy metal does. But it's funny that it doesn't have heavy metal itself. And the reason is that when heavy metal started, it was so much more associated with with the hard rock, so they were correlated. And here, kind of all the softy music you could see. And the other one is kind of all the kind of pop music you could see they're forming here. So now move on to intelligent models, right? So the intelligent models actually quite fun. What I'm going to show you is the word-to-vec. Anyone heard word-to-vec? Yeah, a couple of people. So this is quite interesting. And what you do is that you give it complete text. That's all you do. You just give it a text. And out of them comes, you turn the words into vector. And what you can do with vectors is basically you can do algebra with them. Basically add them up, minus each other. And the guy who did it, Tomasz Mikolov, he obviously had this very important paper. Sorry, I think it was missed here. This important paper, which pretty much revolutionized the text processing so far. So how does it work? It basically works, I mean, there are two different methods, but the essence is the same, is that you, based on proximity of the words together, you build and train it. So it is associated with deep learning, but it's not quite deep learning. So let's take this. Pink Floyd were an English rock band formed in London, right? We want to give this to our model, right? So Pink Floyd, one word, were an English rock band formed in London, right? So if we take the rock in the middle, right, and say these are the words around it, we want to train the model that for rock, you're supposed to see these words around it. And one thing we could do, we could get rid of the escape words, and this is what you see. So the input layer, the word, and we could see here is the input, which is the word rock, and the other one, basically we expect to come out with the other words. Now, that n dimension in the middle, that gets trained and becomes your basically vector. And there is another one to actually do that as well. You could use this model, continuous bag of words, which is the opposite. You say, these are the surrounding words, and I want to get the other word at the end. And kind of does similar things. And basically, you just train the word, train the model break the text into sentence or context, tokenize each word. Sorry, where did it go? Okay. And then feed it to the engine and store the model. And then what you do is load the model and just create a query. Say, like, I want to add this thing with this other thing, which we are going to do. So let's stop this. Let's try. So what would happen if Pink Floyd, right, I guess it's, let me bring this down. So I say Pink Floyd. If it wasn't Roger Waters in Pink Floyd, what would have happened? And say negative Roger Waters. Right? Now I need to remove kind of the text that are not very, like the noise. So I need to mean frequency equal to 100. So you see, probably would have turned into Beatles. Now, the fun thing that you could do with it is that you can actually go and, for example, Nick Mason plus Rolling Stones minus Pink Floyd. What do you expect to find? So, to tell you, this is the common scenario is that they say king, if you take the add king, right, and minus man plus woman, what do you get? You get queen. So if you give Nick Mason the drummer of Pink Floyd, so add Nick Mason, add Pink Floyd, right, and with Nick Mason, but minus Pink Floyd, but add Rolling Stones to it. What you get should be the drummer of Rolling Stones, which we're gonna try. Okay, it's very high. I need to. So Pink Floyd is fine. No, I need to probably just delete a whole lot. Positive. Right. Okay. So positive, I want Nick Mason, right, and the Rolling Stones. But negative, Nick Mason. Did I do it right? Oh, no, I did. Sorry, I need to minus Pink Floyd. Pink. Oh, sorry. Did I add? Okay. Sorry. Right. Charlie Watts. So, I mean, you could do the same thing. For example, David Gilmour plus drums minus guitar. What does it give you? In Pink Floyd, obviously, Nick Mason was the drummer. I mean, it's really amazing what you can get out of it. And or another one like David Gilmour drums minus bass, right? And basically the things that you could get here. So I would like to just pretty much wrap up with one notion that just bear in mind the subject matter that you approach. Try to, I think the previous talk was very interesting in that respect, that your subject matter, even if it is something that is very highly subjective, do look at it objectively. Get some data, analyze it, and try to get objective view on that. And so I wrote this blog post, which basically was my reaction to what was going on in software world. And I saw that people don't look at the scientific side of things. So if you need to take one thing from this talk, I would say it needs to be that. So thank you very much. Anyone guessed who the mystery artist was? Whom did you expected to see and you didn't see? Sorry? Yeah, but the Stooges were there. Sorry? Well, it's not quite rock. Sorry. I think it was somewhere. AC/DC as well. It was somewhere there. Yeah, Queen as well. You know, they were there. So basically, David Bowie, I missed it in my data collection, and the reason was that the info box wasn't quite accurate. So, any questions now? As I said, all the data and the code is available on my GitHub. Question? There was a question there? About the code, sure. Any other? Thank you very much.